Hello my dear students. In this part of video lecture and chapter is redox reaction and topic is oxidation number. In first part we discussed about basic concept of oxidation number. Means we discussed that fixed oxidation number, more than one ox number, then some amalgam or ox number of mixture or ox number of alkyl group involved. And for on behalf of that, we will make our calculation on redox reaction chapter, and the topic is oxidation number calculation or ox number calculation. So how we can make perfect calculation, or how we can calculate oxidation number exactly as examiner is asking, correct? So first of all I would like to recall the concept. Students, ox number of atom is 0 because there is no charge. Ox number of molecule is 0 because there is no charge also. And next, ox number of ion. So whatever the charge of that particular ion, it is ox number of that particular species, correct? Because as per definition, ox number is nothing but it is total actual charge present on species. So and next we discussed that ox number of alkali metal in their compound, it is +1. Ox number of alkaline earth metal in their compound, it is +2. Ox number of individual molecule like S2, P4, S8, O2, it is 0 because it's belong to molecular category. Or some more than one ox number like oxygen. In normal oxide, ox number of oxygen is -2. For superoxide, -1/2. For peroxide, -1. And for hydrogen, when it is connect with metal, it is -1, and it is connect with non-metal, it will be +1. So etc. Correct? So we will see one example that I have to calculate ox number of underlined atoms in the following. So he is asking ox number of Mn in KMnO4, correct? So students, KMnO4 is molecule, complete compound, and he is asking atom inside the molecular compound, correct? So name is potassium permanganate. So I know some ox number of some particular element like potassium. Potassium belongs to alkali metal category, and we know as per the bulletized summary, ox number of alkali metal in their compound is how much? It is +1, correct? So I took +1 from that side, na? And for Mn I have to calculate, and for oxygen it is -2, and 4 number of oxygen will be multiplied. So students, you will be curious, you will be face some problem. You can face some problem that why I took -2. So there I discussed in my previous video lecture ki for oxygen there are 3-4 category, but we will prefer -2 as no information is available. Means we will consider oxygen as -2 or normal oxide until and unless some data is not provided by the examiner, correct? So I will consider oxygen as -2 in almost 95% cases. I will discuss some cases where oxygen is -1, -1/2, +1 and +2 in different examples. So we will discuss that in second part or next part of this video, correct? So for potassium it is +1. For manganese it is X because I have to calculate. For oxygen it is -2 because I have to consider it as normal oxide, and 4 for number of oxygen. So answer will be +1 plus X -8 equal to 0. Answer will be +7. What is this +7? This +7 is ox number of Mn, manganese in KMnO4, correct na? See, potassium dichromate, I have to calculate chromium in potassium dichromate. So number of K is 2. So outside the bracket, what is the ox number of potassium in potassium dichromate? So students, we have data, same thing. Ox number of alkali metal, because potassium belongs to alkali metal category. We have to little remember the concept, correct now? So ox number of potassium in the compound, that is K2Cr2O7, because potassium belongs to alkali metal category. So ox number of alkali metal in their compound is always +1. So I took +1. Then 2 for this chromium, and X I have to calculate. Correct? No issue na here. Next, +7 -2. Why +7? Because number of oxygen is 7, and I have to consider this oxygen as normal oxide. It is -2 equal to 0. Means because no information is available regarding peroxide, superoxide, normal oxide, so that I will put -2 almost 95% time. Correct? So answer will be +2 plus 2x minus 14 equal to 0, 2x equal to +14, or x equal to +7. What is this x? I have to calculate ox number per atom. It is very important. I will not report my answer as 2x because I have to calculate ox number per atom, right? So x equal to +7, and +7 is ox number of chromium in K2Cr2O7. Now same thing we can do for potassium chlorate, KClO3. For K it is +1 fixed. For chlorine it is +x. For 3 and -2 for oxygen, answer will be +5. So what is this? Ox number of chlorine in KClO3. Correct? So students, ox number of alkali metal is fixed. It is +1. Alkaline earth metal, it will be how much? It will be +2. Correct? So next, some bracket concept. K for FeCN6. 4 outside, +1 alkali metal. X, Fe I have to calculate. Cyanide, Cn. Students, cyanide is ion. I mentioned the charge of cyanide ion in my previous video lecture. It is -1. So -1. Correct? 6 into -1 equal to 0 because no charge. Students, in all other cases, I mentioned equal to 0. Why? Because here no charge for that particular molecular compound. Correct? So I have to mention it is 0. See here, again 0, answer will be +2. For H2SO4, 2 for hydrogen, +1. Students, for hydrogen I have two category, +1 and -1. I used to write +1 for non-metal hydride and -1 for metal hydride. Correct? So here, because H is connected with non-metal, so its charge will be +1. Correct? That's why it is +1. Now +x +4 -2 equal to 0. 4 again and -2 for normal oxide. Answer is +6. Correct? So what is +6? Ox number of sulfur in H2SO4. Next is nitric acid. H2SO4 sulfuric acid. HNO3 is what? It is nitric acid. So I have to calculate ox number of nitrogen in nitric acid. So again, H is connected with non-metal, that's why +1 +x +3 -2 equal to 0. Answer is x equal to +5. So it is what? Ox number of N in HNO3. So students, it's all about neutral cases. Now some charge is there. Carbonate ion, charge is -2. So what will be my next step? So for carbon it is x, because he is asking. 3 for oxygen, and its charge is -2 equal to -2. This is very important. Why? Here no charge, that's why I took 0. But here charge is -2, so I have to write right side to the equal sign. It will be -2 because the whole charge of molecule is -2. Correct? So answer will be +4. What? It is ox number of carbon in CO3 2-. So if I would like to calculate ox number of Mn in permanganate ion. So x 4 for oxygen, -2 its charge, and -1 is charge which is bearing by this molecule. So it is overall charge of the molecule. So total answer will be x equal to +7. It is ox number of Mn in MnO4-. Correct? Next, NH4 positive. Overall charge of molecule is +1 now. So I written in right side of the equal sign. X for nitrogen, 4 number of hydrogen, and +1 is again charge. Whatever I written in the bracket, in all other cases it is charge of that particular species in the compound, not individually. Remember, ox number of Mn, ox number of K, ox number of sulfur, x number of hydrogen is in their compound, not individually. Because individually it is atom, and for atom I have to mention 0. Correct? So here X for nitrogen, 4 for hydrogen, plus 1 charge of hydrogen equal to plus 1. Students, why I took plus 1, why not minus 1? Because H has two category na, plus 1 minus 1. So if H is connected with non-metal, it will be plus 1, and if H is connected with metal, it will be minus 1. So because here H is connected with nitrogen and nitrogen is plus 1, so its answer, its charge will be plus 1 and answer will be minus 3. Some complex case, FeSO4 dot NH4 twice SO4 dot 6 H2O. It is ferrous ammonium sulfate, correct? So it is complex. So collectively for X, for Fe it is X. For sulfate I took complete charge of SO4. Sulfate I mentioned in my previous video lecture, charge of ion. So charge of sulfate is minus 2. For ammonium just I calculated, it is plus 1. See, and 2 I multiplied because 2 number, sulfate is again minus 2, and 0 for water because water is molecule, it is neutral, so it will be 0 charge. So just I took collectively, collectively means not separately, so I have to calculate sulfur and in a complex case, not in general, correct? So X minus 2 plus 2 minus 2 equal to 0, X will be plus 2. What is this? This is Ox number of Fe in ferrous ammonium sulfate. And next is NaH2PO4 or structural based example. So students, such kind of problem, such kind of structure I will take my in next video lecture. In part 3 I will discuss how we can calculate Ox number of structural compound, means where structure is involved, where double bond, single bond is involved, where we will see again some problem based on complex compound also. So there are little sequential, so we will go ahead step by step. So we will again meet in my next video lecture, that is part 3 of redox reaction, and topic is oxidation number calculation part 3. So till then, thank you, thanks a lot.